right, we're on page 4 of the study guide. Question 20, I think it might look hard at first, but it's not that bad. If B is parallel to C, remember that's our sign for is parallel to, I'm going to go ahead and mark this on my diagram. If B is parallel to C, find X and Y. So even though these are vertical angles, and we know vertical angles are always congruent, we do not want to set up 5x plus 20 equals 9y minus 18. At least we can't solve it with that one equation. But if I just kind of cover one up at a time, I could see how they relate to this angle. So I might notice that this 100-degree angle and 5x plus 20 are corresponding angles, therefore they are congruent. So 5x plus 20 equals 100. All right, so from here, I want to subtract 20 from both sides. I get that 5x is equal to 80. And then I could divide both sides by 5. And therefore, x is equal to 16. All right, so now if I think like, how does this one relate to this? Well, we know these are vertical angles, so I know this will also be 100. Or I could see that these are alternate interior angles, 9y minus 8 and 100. So if I set those equal, because alternate interior angles are congruent when those lines are parallel. All right, so I add 8 to both sides. So 9y is 108. And then I divide both sides by 9. And you're welcome to use a calculator. That should be 12 though. So y is equal to 12. All right, that's all we have to do for that one. Number 21, I think what looks confusing is that we see a lot of numbers in here. 1, 2, and 4, those are just meant to be like the label for the angle. So I could think of this as angle 1, angle 2, and angle 4. It is not meant to read like that that's 1 degree. Whereas this is 33 degrees, 59 degrees, and whatever 5x plus 2 is, it's that many degrees. So we're asked to find the measure of each angle, so angles 1, 2, and 4, and then the value for x in this one. So what I'm looking for is anything that jumps out to me as like vertical angles, linear pair, anything I remember. I see vertical angles right here, 33 and angle 2. If I cover that other line up, I can see clearly that these are vertical angles. And we know vertical angles are congruent, so that means they're the same. The measure of angle 2 is 33 degrees. Then if I look at these two angles, they're also vertical angles. So the measure of angle 4 is equal to its vertical angle, which is the measure, or which is 59. So the measure of angle 4 equals 59 degrees. These are obviously not drawn to scale. That's way bigger than 33 degrees there. And then lastly, I want to find out the measure of angle 1, but I want to actually know what it is in degrees, not to write it as 5x plus 2, because these are, again, vertical angles. What I could look at, though, is I notice that this angle plus this angle plus this angle all make a line. So I know that that's 180 degrees, that big angle. So I could say, all right, 33 degrees plus 59 degrees plus the measure of angle 1, which we don't know what that is yet, all of those have to add up to 180. All right, so now I can combine my like terms. So that should be 92. I still have the measure of angle 1. So 92 plus the measure of angle 1 equals 180. And this is just like having an x or something in your equation. It's a variable. All right, so now I could subtract 92 from both sides. And I could say the measure of angle 1 equals, let's see, that's going to be 88 degrees. All right, so now we have the measure of angle 2, the measure of angle 4, the measure of angle 1. The last thing we need to do is to solve for x. So if we look over here, we know that angle 1 and this angle with x in it are vertical. So we know that 5x plus 2 must be 88 degrees because we just found out it was 88 up there. So I want to subtract 2 from both sides. And what's kind of yucky about this is when I do that, I get 5x equals 86. And I know that 5x, I know when I divide by 5, I'm going to get a decimal or fraction, but that's okay. I know we work a lot with whole numbers, but it doesn't mean we can't get a decimal or a fraction. So you feel free to use a calculator there. We should get 17.2 for our value of x. All right, moving on. I think the rest of this actually gets easier because it's kind of more stuff we've been doing heavily. So in number 2, find the equation of the line to the right. So we are using our slope-intercept form. That means to find the equation, I need the slope and I need the y-intercept. And I could see someone has very nicely marked off 2 good points for me to use. So if I look first at my y-intercept, it's at the ordered pair 0, -1. So my y-intercept is 0, -1. Just kind of cluster that together. All right, so my b value is the -1, and y equals mx plus b, the -1 right there. The other thing I need is my slope. So remember, we reviewed slope in class. We said it is rise over run when we talk about it on a graph. And we have to be really careful when we are looking at a graph. We read it from left to right. So if my graph is decreasing, if I'm from left to right, I'm going down, my slope is negative. And right, m is negative. All right, so we know our slope's negative. People forget that all the time. So if I connect these, I could look at my rise and my run. My rise is really a fall because I'm going down. 1, 2, 3, 4, 5. My run, I'm moving over 1, 2, 3, 4. So my slope is -5/4. All right, so I need only put this information together now in this equation. So y equals m x plus b. Instead of plus -1, I'm going to write -1. All right, and there we go. That is our equation. Moving on to number 23. Find the equation of a line perpendicular to the one at the right, the one we just worked with, that passes through this point. So now we're going to really use this equation. So I have to ask myself, if my slope up here is -5/4, what is my slope of this line? Remember, there are 2 things. We have to change the sign, and then we have to flip it to get the reciprocal. So my slope is +4/5 for this one. My y-intercept's not going to be the same. I don't need that -1. I need to find b. So if I go back to my y equals mx plus b, that's just my slope-intercept form. I know m is 4/5, so y equals 4/5 x plus b. I'm given a point, so I'm given an x and a y to plug in. I'm going to plug 1 in for y. My m is still 4/5. I'm going to plug 4 in for x. And then I've got a plus b over here. Again, I think we're going to see some stuff we haven't seen on the mile marker. So when I multiply 4/5 times 4, I get 16/5. And I think we're used to getting a whole number there. But just because we don't get a whole number does not mean that we've done it incorrectly. It does mean, though, that I've got to be really careful. So now, if you are more comfortable using a calculator, you could work with this as decimals from here on out. So I could change 16/5 into a decimal and work with that. Or, because I'm going to have to subtract this from both sides. Or I could rewrite my 1 as 5/5 so that they have common denominators. So I could have 5/5 equals 16/5 plus b. All right, so now I'm going to subtract 16/5 from both sides. Oh, this is getting a little yucky. All right, so really, I'm doing 5 minus 16. fifth, and it's fifths, but 5 minus 16. So 5 minus 16 is going to be negative 11. So I get negative 11 fifths is equal to B. Now, if you don't like doing it that way, bring a calculator. I can't guarantee that we'll only have whole numbers on our test. So you could always turn that into a decimal and use a calculator, and you won't get the wrong answer. So if you do it with a calculator, negative 11 fifths, well, that's the same as negative 2.2. So either of those works for B. So when you go to write your equation should either be y equals 4 fifths x minus 11 fifths, or y equals 4 fifths x minus 2.2. These are the same, they're just one's got a fraction in it, one's got a decimal. All right, lastly, number 24, last on this page anyways, is the line y equals positive 5/4 x plus 3 parallel, perpendicular, or neither to the line in question 22. So what we got up in number 22 was y equals negative 5/4 x minus 1. And I don't care about the minus 1 to answer this question. So one is negative, one is positive, so they're not the same, but also we never flipped them, so they're not reciprocals. So our answer here is neither or neither. So we could say they're not parallel because slopes not the same. Say slopes are not the same. They're not perpendicular because slopes not or are not, I'm sure your English teachers love this, are not reciprocals. All right, that's it for this page.